Hello.
Hello.
How are you?
Hi. Yeah, good to see you.
You
Is this
too.
Claire?
Yeah, yeah. Hi,
Hi,
nice
nice to
to
meet you,
see you.
Claire.
I haven't been to one of these. I kept missing out
Oh,
of
no
them.
worries, no worries. I'm glad you were able to come. I just checked out of the room because I wasn't sure if anyone was here. But yeah, anyways, I've checked back in. So I wanted to just let you know that it's gonna be recorded.
Yep,
But we can if you want to take things offline after this, we can sort of shut off the recording. But
sure.
maybe first, I'll just sort of ask very briefly, maybe it's a little bit about your background and sort of where you're coming from, and then sort of we'll dive
My
into
my skill
yes,
so
yes,
far. um, so I'm in marketing, and it's spent a lot of time kind of in advertising sales as well. And so a lot of we've analyzed a lot of data and spun a lot of data in the past.
I
Um,
think I remember reading this in the forums.
yeah, that's right. So
Thanks by the way for your participation. It's been awesome.
oh, great. Yeah, I do. It is quite nice interacting with people.
Yeah,
Um, so and yeah, I do love the classroom. So I do miss that aspect of it. So these are nice to do this in the forum works
yeah,
in that way. Um, so at the moment, so I work at Xero accounting software in our internal advertising agency. And
right.
so when we receive briefs, some of them are data led, some of them aren't, but a lot of our work is also around our website. And so I do see a lot of that data statistical significance all makes sense to me when because we do a lot of testing on what things will work. So a lot of the examples are actually quite marketing examples that I've read through, and that's kind of made sense to me.
Great.
What I have had trouble with is trying to figure out how would this practically work in my industry.
Uh-huh.
So some of it is a little bit, oh, like is this would I really need to would I really need to do this sort of stuff? I don't know, but
Yeah.
maybe. I mean, it'd be a good exercise because as a group, what we're doing is each of us are coming up with an idea for our assignment for our final assessment,
Oh,
and
cool.
we're going to work out which is the best sort of option. So, so that's a good challenge for me to figure out. Okay, how could I take a bunch of data and use some of these
Excellent.
practical things? So working through that. I guess a lot of it made sense. Probability was okay. I got through the regression okay as well.
Fantastic.
Um, and and I watched back that video that you did with Adam last week,
Right.
which a lot of that stuff was also getting a little bit over my, bit
It's a
stressed
little
for a
long.
little bit.
Yeah,
Like,
yes, yes.
so just hearing your explanations, that's when I thought, okay, maybe you can help me with this one because when I started working through the exercises in Unit 6,
Yep.
um, it sort of dived right in and said, build this thing. And I was like, okay. And I tried and then I looked at the answer and went, I am way off.
Okay, okay,
So I
no
think my
worries.
logic wasn't
No,
working
this
there.
is
So
perfect. No, this is good to know, and thank you for flagging this because I think with every cohort, we have different perspectives and people come with different backgrounds, and so it's good to know.
mhm.
So every time we have some people might have an issue with chapter 3, some might have with chapter 6, some with chapter 9, and every time is different. So we're
Yeah.
trying to, obviously, we'll improve it
So you're kind of
as
like
we
taking this as feedback as well.
yeah,
Yeah.
exactly.
Yep.
Yeah. So,
That's fine.
but yeah, so last time for some reason, we didn't have an issue with this, but this is perfect because I think both you and Stefano, I mean, the two that voiced it. So I think I'd love to maybe give you like a brief overview, and then I'll dive
Mhm.
into one or two examples that are outside of the book. So then you can go back to the book because I think if
Okay. Yep.
I mean, I can also go through the book examples, but I feel like it might be a little bit boring because we'll be just sort of going through it, again. Whereas if I present maybe a new simplified example, maybe then you can apply to the
Build on
examples in the
that.
ebook. Yeah, exactly.
Yeah. Okay.
So I'm going to go ahead and share my screen. And let me see if I can find it. Okay, so my screen is here. Oh, hi,
Hi.
hi, Jeffrey.
Hello.
Hi, we were just introducing ourselves, or Claire was introducing herself. While I set this up, maybe, Jeffrey, you might want to introduce yourself to Claire if you want.
Sure. Yeah, so I'm Jeffrey, based in Queensland, and I'm an accountant. And yeah, I just find these live sessions kind of useful, just especially early in the morning when I'm fresh.
Yes, me too. Because by the evening when I get to study, I'm like, and
Yeah,
maybe that's
'cause
why some of it's going over my head
I
as
have
well.
a 11-month-old baby, and
Ah,
at nighttime I tend to be a bit drained. And
that's fair enough. Oh, so you're an accountant. So is a lot of this work, like, are you understanding a lot of this then? Or
I am, and I did economics last term actually, and they
okay.
have they do game theory, which is very similar to a payoff table or a decision tree.
Okay.
So I'm familiar with it, but in terms of like doing it, it may, I don't know, it's helpful to just view these and then just you get more efficient and you can do it faster.
Yeah, I think that's exactly right. So I think there, some of the words here like payoff table and decision trees, like they sound, I think in my mind at least, would love to hear your feedback once we've gone through this exercise and we've gone through some exercises. I think they're bigger names than what they're really, what they're really meant. And it's sort of a similar thing that happened with chapter 4, I think. Some of the notation looks daunting. When we actually go through it, is actually relatively, at least in my mind, they're relatively straightforward. But we'll see what happens. So Jeffrey, I was just sharing with Claire that I'll go over some other examples outside the ebook, because I think the ebooks, you can do that afterwards. But it might be useful to just have some perspective with an easier example. So I'm going to do like hot dogs and soda drinks, in cold weather and hot weather. So like maybe it's a little bit easier to sort of think about, and also it might be sort of instructive to think, to have another example on how we construct these payoff table and decision opportunity tables. So basically, I'll just do a quick summary of sort of this chapter. We'll be focusing. So we'll be just looking at the payoff table and decision trees, and then the opportunity loss, and then we'll go through. We're not going to go too much through the criteria for decision making, unless you guys want to, but it's basically, we'll talk about the relationship between the opportunity loss table and expected monetary value, as well as the expected profit under certainty, and then we'll touch upon, if you guys want, sort of utility and other things. But for the most part, I think I just want to go through the basics, because I think if that's what's tripping you up, then everything else won't make sense. So I want to make sure you guys have the foundations. And I think the foundations, from my point of view, or from our point of view, there are just a few things we need to think about when we talk about decision making. And this is actually a course topic in itself. So there's there's several courses that come after this. So there's managerial decision making, and I think there's also I forget, there's another decision making under uncertainty. Those are 2 other courses. And so this is just a very brief introduction, which ties together some of the notions that we've developed in units 3 and 4 from probability and statistics. So the key features here are, we just want to be able to list our alternative course of actions in the decision-making process. And then we just list the possible events or the outcomes of what's going to happen. And this may, I think once we do it, it might become a little bit more obvious, hopefully. Then you just, once you have those pieces, then we want to, calculate or determine our payoffs. And so we basically will, calculate a payoff with each course of action and an event pair. And then there's a notation with a notation there, which is similar to the notation that we developed in our last office hours for the expected value. And so that notation is going to be sort of carried over from here. And then finally, we'll sort of talk about a little bit about sort of, how do we evaluate the criteria for selecting the best course of action. And the reason why we're going through this, and I think you mentioned this, Claire, like what, you're having some questions in marketing, whether or not you would actually use this. And that's actually a really great question. So I think with Xero, I'm not familiar with their operations, but I can tell you that in a lot of other data-driven organizations, Xero sounds like it might be one of them. So it'd be good to get your feedback as well. There's a lot of data-driven decision-making processes that are starting to be developed for marketing analytics, and particularly, they're sort of newer trend, and sort of where marketing is becoming super technical, and often using AI and stuff. And so we're going to build towards that towards the end of the course. Now, whether or not organizations end up using it, I think it depends on leadership and their familiarity and sort of the skills of the organization and their people. And so there's an element of sort of change management involved there as well. So, for example, we work with some organizations, even organizations like PwC or KPMG, where they need to upskill some of their workers to understand sort of how do we implement this. But I think at a high level, we're just introduced. This is like we're just doing a little tour of some of the sort of the key things you need to understand that when you have conversations, either with your direct reports or with C-level or executives or at the board level, that there's some fluency with this language. So that's all. So this is a very deep, like we've basically compressed. I think I might have said before, we've basically compressed like 5 different courses, 5 like full-term courses into one, and we're giving you the highlights and tying together the different pieces so that you can then figure out later on which other courses you might want to dive deeper into. So we'll just dive right into sort of the heart of what we're going to be doing, sort of the questions I think that surrounded both Stefano and yourself, sort of how are we going to construct these tables? And they're just basically when we're talking about listing actions and events, are basically two main ways. There's decision trees and payoff tables. Today we'll focus more on payoff tables, but we'll also just slightly go into decision trees just to show you what that illustration looks like. So for the payoff table, they're basically just two main steps. So let's say you are you're a food vendor. Let's say you're a what are they called, pop-up food trucks, and you're determining whether to sell soft drinks or hot dogs. And then you have to consider the weather, whether it's a cool day or a hot day, or which season it's going to be. And so one thing that's very it's sort of mechanical and a little bit boring, but you do need to be careful with the notation just when you calculate the payoffs as we were discussing. So when you talk about the what we really want to figure out is the payoff for every event I, which is cool weather or warm weather, then we call it E of 1 for cool weather and E of 2 for warm weather. And then, can you guys see my mouse here, my mouse cursor? Yeah. So I'll just point out, yeah. So this E of 1 corresponds to the event I, and then the action. So do you want to sell soft drinks on that day or hot dogs? Obviously, there's a very simplified example, but the simplified example will give you the tools to take in more complex examples. And so in this case, the action is either A of 1 or A of 2. And so we the payoff will just denote as Xi of J. So it sounds, hopefully that's not too cumbersome, but unfortunately, just for clarity, that's just the way we describe these decision processes. So the other thing to note, which we're not going to go into too much, but I'll just do a very quick demonstration of it, where when you have a lot of different actions and events, sometimes we can help eliminate some actions that don't make sense. And we just call, like, say action A dominates action B in the particular payoff situation, or action A might be inadmissible if it's dominated by another action. And let me show you what that means. So here in this payoff table, we have 4 different production processes, A, B, C, D, and then we have 3 different levels of demand, so low, moderate, and high. And the key thing to note is, let's just focus on production processes C and D. And you'll note that for each level of demand or every event, C is gonna, what we call dominate action D. Well, in the low level demand, it doesn't dominate, it's equal, but it is dominated in moderate and high situations. So in this case, you can automatically eliminate this scenario. Whereas, for A, B, and C, they all have different trade-offs. So in the low situation, C is better, but in a moderate situation, C is also better. However, in a high level demand, we find that A is better than B and B is better than C. And so there are different trade-offs here. So we're going to include all 3 of these production processes in our construction of our payoff table. And it's just a simple way just to say, like, when the payoff tables get bigger and larger, this is just one easy way to eliminate certain decisions. Now, just to illustrate, and I think we have some examples in the ebook as well, but another way to illustrate this is a decision tree. So whether or not as a vendor do we choose to sell soft drinks or hot dogs in a cool weather or warm weather, this is one way to express the decision-making process, what the payoff is for each of these actions under each of these events, whether it's a cool weather or warm weather. So now let's go into I think the thing we should center our attention for this, based on the feedback I got from Claire and Stefano, is for the opportunity loss example. Let's use this simple example where we have, again, sort of, let's focus, let's say in a cool weather event, the action is to either sell soft drinks, or the alternative action is to sell hot dogs. And the key definition here is we think about opportunity loss in terms of the highest possible profit for an event. So in this case, we're just going to look at only cool weather and the actual profit obtained for an action. And so here, I'll just take a little break here after I go through this, just to pause. But basically, the opportunity loss that we would calculate here is the maximum profit for selling in a cool weather event is going to be, Claire or Jeffrey, do you think it's going to be hot dogs or soft drinks? Do you remember the situation? So basically, the situation here is, so when we sell soft drinks in cool weather, it's going to be $50 of profit.
Yeah, it looks like hot dogs.
Yes, it's going to be hot dogs. Exactly. Perfect. So basically, we have to define the first piece of this equation. The highest possible profit is going to be $100 no matter what. So we just, by definition, but don't think about it, just by definition, you just need to say 100. Then you think about, okay, the operating loss for selling soda in this cold weather event is $50. So another word we use is regret. So this is a regret of $50 that you could have made versus, say, if you sold $100 worth of hot dogs, you would have $0 regret. So this is just one approach to decision making, is using the opportunity loss framework.
So this is the opposite of, so you want the highest number here. Oh, sorry, the minimum number.
Yes,
here.
you want the minimum. So you want to optimize for reducing your regret of making this decision.
Gotcha.
And I'll later relate the opportunity loss to expected monetary value. They're actually equal to each other. But before we go there, so now if we want to build out the entire table, so we just did it for cool weather in that example. Now we build out the warm weather. So just to refresh, this cool weather example is 100 minus 50 for soft drinks, 100 minus 100 for hot dogs. Now we just do that for warm weather. And now in this case, the profit of the optimal action is going to be $200. And again, we always have to anchor around the first term here is always going to be the maximum. So it's 200 minus 200 for soft drinks and 200 minus $125 for hot dogs. And in this case, this is what the opportunity loss table is. So it's just mechanically filling out. So I think sometimes this is where you can get tripped up. But maybe I'll just pause here and just make sure that we have an understanding of how this loss table is constructed.
Yeah, I think where I got tripped up here in the examples was the double negatives.
Yes, the double negatives.
When and where I do that, yeah.
Yeah, so in the case of the marketing of the new media, so you're launching some media catalog, I think $5,000 is the I think it's noted as minus 5,000 or $5 million or something like that. Is that right? So you have to do minus $5,000, which is sometimes not, or sorry, $5 million. So I think that's sort of where the confusion is. But because it was a negative in the first place. Yes.
So it's always
exactly.
that minus whatever that number was, and that was a minus 5 million.
Exactly. exactly. So that's just, so I believe in the new media case in the ebook, you know, that term is going to be minus. So then you have to, you know, add that term here, which is not denoted here because we don't have
I see, because we didn't have a negative. So here
Exactly.
it's just a,
exactly.
right.
So
Yep.
so that's where that notation can be confusing. But you know, in the new media case, you can just imagine the company had already invested $5 million to build this new catalog. So it's already, you know, it's already written off. No matter what decision you make, you have to take that into account. So that's probably
I think that is because both examples kicked you off with a negative number to
yes.
to minus from. So I think this one, you're right. This is a simpler example that's already starting to make more sense.
Good. Yeah. So I chose this example because it's simpler. We don't have to deal with negative numbers. Yeah. So hopefully this makes sense. And just remember that when you look at the ebook examples, you'll need to have that minus 5 million, and then you'll come up with the correct payoff.
Okay. I think because I wrote here, is it because it's less than 0 that you don't do it? But I realized it's because there wasn't an example that didn't have a negative. So, okay. All right. I'm getting it.
So yeah, no, that's fine. No, so I think so I think maybe for the next version of this, we'll maybe have some simpler examples first and then build it up. But in any case, some people have had a lot of experience with decision tables and others may not. So this is good to know. All right. So then when we talk about the decision criteria, so we've gone over the expected opportunity loss. We'll briefly go into the relationship between the expected monetary value and the expected value of perfect information. So just briefly, just in case if this was not clear, so for the expected monetary value, this notation here can be confusing, but I just wanted to go through it just like we did for expected value. So here, you have basically the number of events here on top of the sigma. You have the monetary payoff of events, which we just discussed in the previous example, and then the probability of events. So for example, the probability of hot weather versus cold weather could be 50-50, it could be 30-70, you know, whatever the case may be. But this is just a notation we use so that we can calculate the payoff. So then we can come to a decision on which one we want to do based on the events that are given to us and the probability of those events. So in the case now we're going to go through the hot dog example again. So in this case, we're just going to say, you know, we have a 50-50 chance of having a cool or warm weather event. And in this case, again, we're going to have the monetary value of the soft drinks be $50. In the cool example, $100 for the hot dogs, and then you know $200 in the warm event, and $125 for hot dogs in the warm event. And now, do you guys? In my view, I have your faces including this. Do you see that too or not? Okay, so maybe I'll need to move this around here.
No, I don't. I see just the person talking. That's what I see.
Oh, okay. Okay, so can you see the full slide?
Yeah, I see the full slide and then you beside it.
Oh, nice. Okay, so I don't need to move anything.
Yeah.
Okay.
Yeah.
Okay. So, anyways, so now what we've done here is based on this notation x I of j and probability by, this really is just mechanics. So we're just taking $50 times 0.5 equals $25 in this example, and then we just do this for all of these situations. So in sum, the expected monetary value is going to be $125 for soft drinks and $112.50 for the hot dogs. So, based on this, so this is a different approach than the expected opportunity loss. And here we would maximize our value. So here we would choose the soft drinks. Does that make sense?
It does, because over time, it's the better alternative.
Yes. Yeah. Exactly.
Okay.
Cool. It looks like we have John here.
Hello. Hi. Sorry, I'm late.
Oh, no worries. No worries. I went over just the expected opportunity loss table with Claire and Jeffrey. and just going over the basics of it. Do you have some quick, you want to just give us a quick update on just sort of maybe, are there specific things that you might want me to cover or?
I had a question about activity 6.8. If we
Okay.
get to that, it's about determining the opportunity loss for the media example.
Okay.
Yeah. So it's
Okay,
just one of the
good.
ideas in the solutions I think is not.
Let's
correct.
do that, because I think that's when I gave up. I'm looking at my notes. I got to 6.7 and then went,
Okay.
sent a message to Lamont.
Cool. So we'll go over that. So it's I think so we did go through a very simplified example of expected opportunity loss, John, and we'll
Yeah,
just sort of
sorry I'm late. I'll go
no,
back and look at
it's fine,
that.
it's fine. I think you came in at the right time. So just to use the same notation for expected opportunity loss, we use the sigma notation. And again, just as we went through in the hot dog example, and John, I can go through this again at the end of it if we need to. But it's a very simple example. So I think if you already got the 6.8, I think you should be able to follow this. But in any case, here we just label the opportunity loss of events here, which we call I sub j, and then the probability events P of I. And so this, when we go through our opportunity table, these are just the terms that we use to calculate this. So in the hot dog and soft drinks example, this is the way we would go through it. So the opportunity loss for soft drinks in this example would be $50. The opportunity loss of hot dogs would be $0. So does anyone want to tell me in the cool events, which one would you minimize your regret? Selling soft drinks or hot dogs in the cool weather event?
The hot dogs.
Yes. Hot dogs. Yes, hot dogs. So no, this is perfect. No, this is perfect. No, no, this is fantastic, because don't worry about getting it wrong, because it can be confusing because we're doing the inverse here. So instead of
Yeah, so we're looking for the minimum.
We're looking for the minimum here, exactly. Yeah. So anytime we think about expected opportunity loss, we're always trying to minimize what we call regret. So so that's one way to think about it. That would hopefully simplify the way we think about these frameworks. So in the warm weather example, can somebody tell me which one would you want to minimize your regret? So which do we choose, soft drinks or hot dogs?
Soft drinks.
Soft drinks, yeah.
Yes, exactly. And then so this is just simply so this is just the nature of these expected opportunity loss tables. You're always trying to minimize the regret. And so overall, on average, which one would you choose to sell from an expected opportunity loss approach, whether it's cool or warm on average?
Soft drinks.
Yes, soft drinks. So so in this, so I think if everything is calculated, I think everybody's pretty clear now, like which decision you would make at a high level. And now the question is there anything in the mechanics of this that you guys want to ask right now? Because I think it should be straightforward, but maybe there are elements that are not straightforward. So maybe I'll just do it really quickly. So right now we just chose the probability event as 50%. So that's going to be easy. This is 50%, 50%, 50% for everything. But if it was 30% for cool and 70% warm, we would just change this to 30% here, 30% here, 70% here, and 70% here.
And those probabilities are given to us, obviously.
Yes, yeah, those probabilities are given to you. Or let's say in a more sophisticated example, which Stefano mentioned for 6.6, where we're looking at like, growing or stagnant or, recessive or economies in recession, those are going to be calculated by economists who will have their own forecasts, like what's the likelihood that we're going to be in a recession versus a stagnant or growing economy, which is sort of relevant to what's happening to today, not only for our for companies, but for our personal investments, our superannuation funds, or where we want to allocate our assets. And I'll go through an example so that's related to the one that Stefano mentioned.
I think this is a really good table. Will you share these slides with us after?
Sure, absolutely.
The way it's written here is clearer than even the
The ebook.
Yeah, because it just gives you the 25 rather than the 50 times 0.5. Even though I worked out what it was doing, this
Right.
is really nice to get it really embedded. I
Yeah,
think.
sure. I'm happy to share this. Yep. So then, okay, so I don't know if we want to go too much into this, but just very briefly, for today, when we think about the expected value of crypto information, we're going to relate this to our expected monetary value and expected opportunity loss tables later on. But basically, it just represents the maximum amount you're willing to pay for perfect information. So in the case of the hot dog vet or soft drinks case, right now we have some uncertainty. Is it going to be cold or hot weather, right? And so if there was some way, obviously we don't have a perfect weather forecaster, but let's say you did, that's the amount that you'd be willing to pay some service to make that prediction so that you could either minimize your regrets, minimize your opportunity loss, or you can maximize your monetary value. And that's just basically, so that's given by this equation here, the expected profit under certainty minus the expected monetary value of the best alternative. And I'll show you guys what this looks like. So, a very simple one to expect, in the case here. So we have 50% chance of hot weather or cold weather. So in this case, the expected profit under certainty would be $150. And then the expected monetary value, the best alternative that we calculate above, so I think from here was $125, right? So 150 minus 125. So you would pay on average, you'd probably pay a weather service if you could, maybe $25. That's the maximum you would spend, right? So you probably, if they charge you $25, you might actually say no because you could just do without. But let's say they charge you $5, it would be well worth your money to pay for that information. So hopefully that makes sense that information is a value, and this is how you would calculate how much you would pay for that.
Invest in finding getting that data.
Exactly.
Yeah.
So for let's say Xero,
makes sense.
So in your company Xero, Claire, where you're like you're in charge of marketing, if you wanted to know if you want to launch a new campaign for something, this is how much you would pay to understand like what the market conditions would be, for something like that. So that's one way.
Okay, that makes sense. Yep.
So then you can sort of have some gauge, are you paying too much or too, or is it a good buy? Is one way you could make that decision. Okay, so I'm not going to go into too much of this unless you guys want me to, but the one thing I just want to say is why we have introduced probability and sort of why we introduced statistics and sort of some of these very basic concepts and decision making is because later on when we talk about machine learning, we talk a lot about sort of prior probabilities, new information, or revised probabilities, and sort of how these new algorithms are able to update much faster than humans could. But even just within in the decision-making framework, we still have to talk about prior probabilities and revised probabilities, which then leads into Bayes' theorem, which we can discuss if we have time. But so I just want to just connect some of these concepts for you guys so that you don't think that units 3 to 6 are sort of like it's just sort of isolated. They actually are the foundations for everything that we're going to do afterwards. So so for revised probabilities in the food vendor example, so let's say now that we've already labeled the forecast, or sorry, the events, cool weather and warm weather is 50%. This is our prior understanding. So now I'm just going to go very quickly through this just in case you guys well, how many of you guys want me to go over sort of these revised probabilities and sort of Bayes probability? You want me to skip this for now and go into the other examples? Or would it be useful?
Maybe breeze through it, because what you said about like where everything connects is where I was struggling to like build on it, but it's making sense now. But if you can go over it quickly, if
Yeah.
everyone's
Okay, sure.
with
Sure.
that.
I'll go
Yeah.
over it quickly. So here, let's say so whether or not the weather has been cool, the forecaster has been correct 80% of the time, and when it's been warm, the forecaster has been correct 70% of the time. So we can use sort of this information on the forecasters, sort of how reliable they are, and we can incorporate this into our forecasts. And this can then also inform, our decision whether or not to sell hot dogs or sodas. So very briefly, this is really mechanical. I apologize. There's no way to get around this, but this is the nice thing about machine learning, which you guys have now sort of gone through, is machines make this super simple. You just put it into Python and they'll calculate all this for you. And so all this notation just say, the forecast of cold weather. Let me just make sure I have it right. So when it's cool, they've been correct 80. When it's cold, the forecaster is correct 80% of the time. When it's warm, the other way to express it instead of 70% is that they're incorrect 30% of the time. And then if you just go through this exercise of going through this, you'll find that combining those probabilities together, you get 73% of the expected given cold weather, the forecaster is going to be correct 73% of the time, and given hot weather, the forecast will be wrong about 27% of the time. And so now basically you can now go through the same exercise for the expected monetary value, coming and computing the expected monetary value for hot dogs versus soft drinks, given these new updated probabilities. And so then you come up with a better calculation of the hot dogs versus soft drinks. Does that make sense? So
Yep.
Perfect. Okay, so then you can do the converse, which is the expected opportunity loss. And so in this case, the regrets that we would have where we want to minimize the expected opportunity loss would be hot dogs here, so $20 versus $36. So now we just have a more sophisticated way to incorporate our probabilities and our decision making if we have that information available.
I was going to ask why you would do both, because the answer is always the same, right? Is there ever an example where the opportunity loss is a different option to the other? I can't imagine it would be, right?
Yeah, so I think it depends on risk. So if you look at the,
because when you're looking like stuff with extra zeros,
yes,
it matters.
Exactly. Yes,
you do need to know what your opportunity loss is there.
But it also depends on whether or not you have a risk. It depends on your risk tolerance and sort of the way you view the world. And decision makers have different risk tolerances at different points in time and based on where they are. So like typically a big company will be not wanting to make big moves. They just want to maintain the status quo and just grow at a nice tidy 5-10% a year, whatever it is. But if you're a disruptive startup, you might be optimizing for huge gains, and you might also be, but at a cost of like potentially a lot of risk. And we'll talk about that later on. So that's sort of one way to think about it.
That's really interesting, because at Xero, we are now in that second phase of minimizing those risks, keeping shareholders happy.
Yes, exactly.
Yeah.
So I think the decision-making process is very different at different stages of the company. So I think Xero's gone from a scrappy
that
startup
high risk
now,
startup.
Now it's a risk. Is it listed now or?
Oh, it was listed from day one.
Oh, listed from day one. Yeah. So yes.
Yeah. I mean, I think the change of CEO a few years
ago
is the change to
exactly
looking at opportunity loss more. Yeah.
So and then where this becomes a little bit so when you have additional information on the probability of your forecaster's ability to predict an event, you can now actually better price how much you would pay for perfect information. So in this case, instead of $25, you now, with this additional information, the maximum you want to be paying for this a perfect weather forecast is $20.25 instead of $25. So that does sort of change, like if you have some subscription to a weather, some weather forecast or whatever the case, in your case, marketing research, or in Jeffrey's case, I don't know, accounting, and in John's case, I'd have to think about it for healthcare. I'd have to learn a little bit more about his business, but anyways, I'd have to learn a little bit more about that before I make a comment on that. So anyways, so that's basically how these relate to each other. I'm going to skip through some of this. I'll just briefly say, so this is the utility curves that I was just referring to. So basically, you've got different risk types. You've got risk neutral, where it's very flat. Where it's sort of interesting is, as we discussed before, risk averters versus risk seekers. So startups typically are going to be risk seekers, and large incumbents tend to be risk averters. This tends to be the case. But if you're launching a new product within a company, then it might be along this curve. Those are decisions that you would make. So let me go through. So we've gone through some of the basics of the chapter, or sort of the summary of what we've covered in the chapter, which is how do you construct an opportunity loss table. We've talked a little bit about expected monetary value, and we've introduced a little bit about the expected profit under certainty. I'm not going to go through all of this today because it's going to be a little bit too much. I do want to go into a little bit more detail for the expected opportunity loss, which may address both Stefano, Claire, and John's sort of question. And then we're going to relate, again, sort of the expected monetary value to EVPI, the expected value of perfect information. So here, this is more related to Stefano's question on 6.6. This is a different example, but very related, so that hopefully he can draw from this simple example and apply it to the more to the example in the ebook. So let's say you're an investment manager, or you're just trying to manage your own superannuation fund or your own portfolio of assets. So in this case, let's say you're looking at bonds, stocks, and mutual funds. And then we have three different situations in which we think the economy will go. Is it going to grow or becomes stable, or is it going to decline? And these are going to be the profits here expected under each of these conditions for each of the asset classes. And then again, so you can call this the expected opportunity loss table or the regret table. So sometimes the language helps people understand which decision they would make. So let's just call it regret for now, so they can really understand, like, we're minimizing the regret that we have. So the regret is just, again, just the best payoff that could happen under that condition minus the payoff that you would receive under that condition, as we went through the hot dog and soda example. So let's say for stocks in a growing economy, that would be, we have a profit of $70. In a growing economy, if we invest in bonds, the regret would be 30. 70 minus 40 equals 30. For stocks, it would be 70. It would be 0, because it would be 70 minus 70, and mutual funds would be 17. So then, if you just go through this through the entire table, for let's say you want to do mutual funds, the optimal, you actually have two optimal points here where you would minimize your regret, which would be bonds or mutual funds. And then in the case of a declining economy, it would be 5 minus 13 and minus 5 in the way that it's been calculated. So let me just sort of see. So from the expected opportunity loss approach, this is the table that we would use. And so the two things to note is that the weighted average of the regrets of each decision alternative is going to be calculated through this table. And then the weights are the probabilities that economists in this case would ascribe to a growing, stable, or declining economy. So in this case, let's say it's 20% chance of a growing economy, 50% of a stable economy, and 30% of a declining economy. This, in today's world, it might be, we might switch the probability of a declining and stable, you might, switch those around. So the way we would calculate the expected opportunity loss, again, using the notation that we, the x of ij, this is just mechanically reproduced here. So we just use 20% times 30 here, 0.5 times 0, 0.3 times 0. And if you just go through that, that's equal to 6. And then we just go, column by column, row by row, and we just summate everything to come up with the expected opportunity loss for each of these. And the nice thing about Excel or Python is, it'll calculate this all for you. And so in this case, in this framework for expected opportunity loss, again, we're trying to make a decision that minimizes our loss. So in this case, which one would it be?
The bonds.
Bonds, exactly. So we would invest in this case based on the expected opportunity loss framework. We would want to choose bonds. And this is the same framework that we would use for example 6.6. This is for Stefano. Stefano, I think sometimes some of the confusion occurs in sort of, where, what are we actually multiplying and which way do we multiply? But hopefully through this example, we've made it clear that, we're, at least in the way that this is set up for bond stocks and mutual funds, we multiply across here against the probabilities to come up with expected opportunity loss. So in principle, this is a very straightforward calculation, but let me know if anybody has any problems with this. And so I'll pause here for now.
That's the simplest example. Yeah.
Yes. Yeah. This is So this is a simplified example. So hopefully that builds sort of the knowledge base for you guys to do the ones in the ebook. And I can go to the ebook one as well if you guys want.
Because you can almost set up the table however you want, really, as long as it makes sense to you. The calculations,
exactly.
Right.
Exactly.
Yeah.
So some people might do it instead of aligning it growing, stable, and declining. They would put it on the columns version and the bond stocks and mutual funds the other way. As long as you're consistent and you know what you're calculating, then it should be relatively straightforward. Okay, so so then the last thing is, we should just note that the minimum expected opportunity loss of a decision is equal to the maximum expected monetary value of the decision. But under the two different frameworks, in one you're minimizing loss, and the other you're maximizing value. And so in this case, we've just gone ahead to calculate this for you. This is what the expected monetary value for each of these in the expected monetary value framework versus expected opportunity loss. And these are just, Excel calculations. And the key thing to note is that when you add them together, they all equal 38. So that's something just to note.
That's a good kind of test to make sure you've done all your calculations, right?
Yes, exactly.
Okay, I didn't realize that.
And then, the other thing to realize is that the expected value of perfect information is essentially the minimum of your expected opportunity loss. And so let me go a little bit into this. So in this case, what is the expected opportunity loss here for bond stocks and mutual funds? What's the minimum EOL?
6.
6. Yeah.
Yes, 6, exactly. So so maybe before I say my version of it, does anybody have their version of what they think expected value of perfect information would be? And what could somebody put in words like what they think it how it would relate to your minimum expected opportunity loss? And if you don't worry, I'll explain it, but I'm just curious if anybody wants to take a stab at it.
Okay, I think what it is, So the value of perfect information is the expected opportunity loss um, in the most pessimistic situation. Is that kind of right?
Well,
Or
it,
or like with or or the most yeah, I don't know.
no, don't worry
That
about
right?
it. No, it's almost there. So what I would say, or what we tend to say is that um, in this example, we say that with perfect information, the decision maker will reduce your regret, which we say here is the expected opportunity loss, by 6. So 6. So let's say if you remember in the hot dog and soda simple example, and we're talking about, if it's cold weather, hot weather, we had some minimum expected opportunity loss. I think it's $25. And then, so, when we talk about the perfect information, we had 2 cases. One was where we didn't have information on the forecasters or not, which was $25. And we had one where we had the forecasters predictions, and I think it reduced the expected value for perfect information for to $21.25. And so we would say that basically, the decision to make, would you buy information to reduce that uncertainty? That's the price it would cost. And in this case, it would be $6. So in this case, you might have better information or more accurate forecast of whether or not you have a growing, stable, or an economic recession. And this is the money that you would pay for that. This is the most amount of money.
The maximum,
Yeah,
the maximum you pay.
Yeah, so
to
you
get that
wouldn't,
info.
yeah, exactly. So you wouldn't pay above it. So, the other things that come into your decision, whether or not you would pay for this information, is how clear is the information related to the outcome that you want. So if they just gave you just raw data and your analyst still would have to spend some time to curate it and give you a recommendation, you'd have to calculate that in, whatever that, their salaries and their time to come up with that. But if the report came very clearly, okay, this is the probability of a recession, and you can make a decision based on that, then you would say, okay, if it's like, 5.5, then you might do it because, let's say let's say it's $1 billion or $100 billion worth of assets that you have under management. That's a lot of money that you could be saving with perfect information, right? So that's the way I would think about the expected value of perfect information. Does that sort of make sense?
Yeah, so you look at this table, you choose the lowest value for expected opportunity loss, and that is your EVPI.
Yes. And that's the maximum amount of money you would pay for, like, information that would reduce uncertainty.
Yeah, so someone comes to you and says, oh, it's going to be 50 grand to do this research or something like that. You go, okay, well, show me your
Precisely.
EVPI, or yeah, you can go, have you worked through this and have you understood? Yeah, okay.
Yeah.
This is how it's all relating to decision making and everything.
Yes. So for a
can...
marketer, I'm assuming, I could be wrong on this, but I assume that you would sometimes pay for market research.
Absolutely, yeah.
And then so that can be very valuable, but what price do you pay for that? And so this is sort of one way to think about the price you would pay for that information.
Yes, because we're always trying to minimize our cost of acquisition.
Yes, exactly.
So, okay, now I'm starting to see how I could potentially use some data to come up with a problem for that. How do we make sure we're maximizing our cost of acquisition or using it effectively? Or
yeah,
okay.
So I think for you, I think you're always looking for customer acquisition cost and lifetime value.
Yeah. Yes,
and
exactly.
So you can do either of those in a better way. This is how you would make those decisions.
Okay.
So I think I'm just going to pause here, and then I think that's, I think we're close to the hour, and I want to give some time for questions. Claire, Jeffrey, John, do you have any other questions at this point? And hopefully this makes the ebook a little bit easier.
Just on that last point, like I know this, you might not be able to do this, but obviously when you buy information, you're not gonna get perfect information.
Yeah, of
So
course.
you're
Yes.
only gonna update the
You would be God if you had
probability.
perfect information.
You're only gonna be able to update the probability to a certain extent. So is there a way to calculate it when it's not perfect, or are we just looking at perfect to work out the maximum?
We're just working out the maximum that you would pay, so you're not overpaying.
Yeah.
But
Okay.
yeah. I mean, I think it would be up to the decision maker, and they have their own. You would come up with your own decision matrix on your appetite for risk, or how much you feel like you would actually, how much would you get a payoff if you actually paid for that information. And that's a separate conversation, but that's roughly how you would
Yeah.
think about it.
All right. Thanks.
Yep.
We're looking at it from the purchaser's point of view of that information, not the kind of person who's supplying the information.
Yes. So yeah. You could also think from the other side of the coin as well.
Yeah.
So like for Claire, if you were, if you're doing market research and you're trying to sell to companies, this is one way you could think of it. And then depending on your client base, if you have a lot of them and you're selling the same information, you could actually reduce the price a little bit so that, it's more affordable to all of them. But then at the end of the day, you're maximizing your own profits.
Absolutely. I was at a work event last night because it was end of financial year, and talking to a few people. We do have a data team that I'm going to try and interview and find out what it is they're doing, and if I can get hold of any data that they have, they're okay with sharing and stuff like that, to sort of understand how we use it at Xero a bit more outside of marketing, even because
Right.
we launch new products all the time, and I'd just be curious to see how in depth with this stuff they're going.
Yeah.
Surely they
for
are.
your,
I know they use Python, so.
Oh, that's fantastic. So,
Yeah.
I was going to say, I noticed one of your proposals, and I think if you are able to get permission from your company, I think it'd be a fantastic project to go through. We've got some frameworks here that could be useful, maybe either to you or or to the company. And if you have a large data sets, I think you have the tools now to sort of efficiently go through it. So it could be interesting. And I'm happy to, I'm curious for you guys on your projects. Let me know if you guys are starting to solidify or a scope of some sort. I'm happy to also discuss that with your teams individually, and meet with you guys individually to do that as well.
Yeah. Lamont, I just had one question about calculating opportunity loss, but you may have covered it already in the part of the tutorial that I missed.
Yeah.
But just going back to the new media example in the unit, I'm just struggling with why the decision which is not successful is 20 million and not 25 million, because you would be losing the kind of fixed cost as well. So I'm just not quite sure why it would be 20 million, not 25 million.
Okay. And are you able to
John, I had the same thing when I built my own table. I came up with 25 as well, not 20.
Okay, then that could be an issue. That might be a typo there. Let me just make sure. Are you able to share your screen on that, or I'll find it?
I think so. Just let me see. Share screen.
I hope it's not a typo.
I think it's because it's actually 5 million minus 25. Sorry, minus 20.
Yeah.
So then it actually is 25. I think that might be what it is in the end.
So did you say 6.8, John? Or
So if you just go up to, it's actually written under 6.4. So it's the solution in 6.4.
this one?
Yeah.
Okay, let me just go back to the,
Oh,
Is
it's because it's minus fixed cost is a minus figure. Is that why?
I think that's
Because you're
why it
actually
is.
starting with minus 5 million, because I started with 5 million
Yeah,
instead of minus.
so John, I think we might have covered this in the earlier part, where if you have a minus, you have to take that into account. So when we went through the hot dog soda, the simple case, we sort of, let me just see if I can find that.
Sorry, I have to jump to go to a work meeting, but
No
thank
worries,
you
no
so
worries.
much.
Yep,
And I'll watch
thank
the
you.
rest of this after.
Thank
Bye.
you, Claire.
Bye.
So let me just quickly go through this. Is it this one, John?
Yeah. In the preamble, though, it says, however, if the new media is not successful, a loss of 25 million is expected. So if you're expecting a loss of 25, which is essentially the marketing cost and the fixed
Yes.
cost added together, why is not the opportunity loss $25 million? Because that's the loss you're expecting.
So I think we have to calculate. So if you can highlight it, that'd be great. But I think from my recollection, it's $25 million for marketing costs, but then you also have $5 million for what the company invested to create the new media catalog.
Yeah.
Is that correct?
Yeah. So it's 20 million in marketing and 5 million in the fixed cost.
Yes. And then, so I think you want to add those
Together. Yeah.
together.
So you get 25. Yeah.
Yeah. Oh, so maybe this is a mistake then. Is this a mistake? Let me see.
Yeah, and it flows through all the rest of the kind of activities relating to that. So
Okay.
it might be if that's not right, which I think it is, it might be causing a lot of confusion.
Ah, I see. Okay. You know what? This could be.
Because I get why the opportunity, like the loss, would be 105 million if you don't decide to do it and it's successful. Because we include the fixed cost in that. I just don't understand why you wouldn't include the fixed cost along with the marketing spend in that opportunity loss if it's not successful.
So I think it has some. So I think it might have to do with the way that opportunity loss tables are constructed. But let me. I need to actually look at this in detail, just to make sure I'm not. I don't want to say something, but it could be this. This could be. I'm just trying to figure out the way it's set up here. It looks fine, but conceptually, I think I see what you're trying to say. John, I'll make a note of this, and then I'll DM you once I sort of have a chance to look at this.
Yeah, that'd be great. I'd really appreciate that.
Yeah. Was there anything else? So basically, I'm going to look at activity 6.4 in the calculation of the opportunity loss. Is there anything else that you wanted? I think you mentioned something else.
No, that was it.
I just had a question on this example. Is the 25 million a fixed cost? So is it incurred like in any situation?
Let me just. I need to remind myself of the exercise. So I think isn't 25 million just what they've just is sort of what it would cost to market the new media?
The 20 million was the cost to market, and the 5 million is the development cost. But the total loss is minus 25 million.
Okay, so then I'm just trying to figure out why this is formulated this way, but okay. I'll have to take a look at that. But Jeff, your question was related to this.
Oh no, the 5 million is the fixed cost.
Yes, 5 million is fixed cost.
Okay.
Yes.
All right. So in any event, you spend 5 million.
Yes. You have to spend this much because they already spent the money to create the new media catalog.
The thing I found helpful, we did it last term. It was actually called opportunity cost, but we actually ignored costs that were like I forget the term, but we only focused on the explicit costs because the other costs were not relevant because they would have been incurred either way. So I understand how it is you can get 20 million, but
Yeah, I understand how you get 20 million, but I don't understand then why you would include it in the success, because
yeah,
you know, I think that should either be 100 million and that 20 million, or it should be 105 million and 25 million. But I might be missing something.
So John, so you so just so I understand this correctly, so you think that you understand the 105 million, is that correct?
Yeah, correct. But you're also including the fixed cost in that.
Yep.
So what you're saying is the total opportunity loss there is you're going to make you're going to have 105 million in revenue, but your profit is only going to be 100 million once
Yes.
you deduct your fixed costs. Yeah.
Yep.
So I understand that one. I just don't think that is consistent with that
Okay.
reasoning.
Yeah, I'll need to go through the problem again. It's been a while.
Yeah. So it comes down to the definition, I guess, of how you calculate opportunity loss. And
Yes.
but I just felt those two figures were inconsistent for me.
Okay.
But there may be an explanation of why.
Right. Okay. Yeah. No. Thanks for bringing that up. I'm going to take a look at this after the call. But I think that no. So I think in the hot dog and soda case, I think there was some confusion that we clarified there on sort of how we set up the opportunity losses. But I'll take a look at this one as well.
Thank you. Yeah,
Yep.
and I'll obviously go back and I'll have a look at the bit on with Lamont and that
Sure. Yeah. No worries. Yeah. And so sometimes it takes some time to convert this video and then to upload it. So I'll try and get it to you guys by end of day.
Yeah.
And then yep. But it will be posted in the live sessions and recording sessions area.
Yeah, cool. Thank you.
Great. All right. Thanks, guys.
Okay, thanks a lot.
thank you.
All right.
Bye-bye.
Have a good one. Bye.